Welcome to Massive Open Online course on cartographic techniques. In today's session, we will look at climatic analysis, deviation graph. So, this is the session content today. First, we will see what is a deviation graph, why we need a deviation graph in climatic analysis. Then we will see the procedure to do deviation graph. Then we will do a small exercise on how to do deviation graph with climatic data. Then we will see small summary of what we have seen so far. So, what is deviation graph and why we need a deviation graph? So, we all generally talk about climatic change, correct, but have we ever thought climatic change with respect to what? If we are talking about change, there should be some reference point or some reference temperature, correct. So, yes, what with respect to what the change is, and we usually say nowadays the temperature is abnormally high. If today's temperature is abnormally high, then what is considered as normal? And let us say we all are UG PG students, correct. So, mostly we reconnect the temperature back then with our childhood days. The winters in childhood, it was used to be chill cold, but now it is not the same. Now it rains suddenly, correct, but when we were in childhood, it used to rain during July to August. So, is the weather back then was normal when we were child? All these things we will try to see in today's class. So, research says that normal for normal people means 2 to 8 years back. So, for every person the definition of normal changes, the timeline for normal changes. Climatic analysis, scientists have come up with climatic normal. So, what they do is they take arithmetic average of climate variable such as temperature or perception over a period of time. Usually this period is 30 years. This represents a yearly variation of climatic variable from a long term climatic normal. So, what is long term climatic normal? The 30-year average we consider as, and the graph which we plot with yearly variation over the climatic variable, that is the average climatic normal which we have taken for 30 years. We will plot yearly graph with respect to this 30-year average. That is what our deviation graph is. Okay, this is also referred as anomaly graph. Anomaly is nothing but it refers to deviation, the change with respect to annual or normal temperature. It effectively highlights climatic anomalies and extreme events. So, just with respect to temperature over a period of time in a Excel sheet, we can't even predict more insights, we will not be getting more insights on that. If we plot a deviation graph, then we can see whenever we had high precipitation or when we had high extreme temperatures, either cold or hot, all those things we can get insights using deviation graph. So, it helps us to distinguish between normal weathers, fluctuation from significant climate shift that may require adaptation and policy response. So, if there is any significant change happening in climate, gives us the policy makers to respond quickly. Effectively highlights the climatic anomalies such as wetter, drier, hotter or cold condition. If let us say the temperatures are getting really cold or it is getting extremely hot, all these insights we can get from deviation graph. It assists in identifying hidden patterns, long term trends and extreme events through time series visualization. So, here we have a graph, this shows shift in normal global surface temperature. We have seen what a climatic normal is, right. So, is this climatic normal even normal, is this say consistent? If we say even this 30-year variation keeps on changing year after year. So, here we will see how this climatic normal has been shifting over 1951 to current date. So, here climatic normal for 1951 we have considered as base. So, this x axis over this years from 1950s to 1920 we have plot the variation in climatic normal. So, this y axis shows us the climatic shift in climatic normal, how is this climatic normal is being changing. So, if you see in 1961 to 1990, this 30 years there is a increase in 0.1 degree Celsius, correct. Here it has increased by 0.1 degree Celsius, then 0.21, then now in 2020 if you see the temperature has increased by 0.6%. 0.6 degree Celsius. In an American lifespan, if you see in a lifespan of a person, the earth temperature increases by 2 degree Fahrenheit. Okay, so how this impacts the earth surface? Let's say we are in a normal body temperature. If we get a 2 degree Fahrenheit increase in a body temperature, we used to get fever and we become ill. But over this period of time, if the earth temperature increases by 2 degree Fahrenheit, we human tend to have a higher metabolism, so it doesn't affect us much. But the small species, small insects, plantations, some are very sensitive to this temperature, so they tends to affect with this increase in temperatures. So here in this diagram we can see this illustrate the temperature abnormality relative to baseline. So here this is our baseline. Baseline means the 30-year average which we have calculated. So our climatic normal is long term period average, right? So usually it's 30 years. So if we are considering from 1991 to 30 years, 2020. So this 30-year climatic data we will take an average divided by 30. So whatever we get, that we will plot it in as a baseline. Okay, that will act as a baseline, and for year after year from 91 to 2020, we will plot each year's data here. If it's cold, hot, if it's positive, so whatever data we have, if it's positive, it will go on warmer side. If it's a negative value, that means it's colder that particular year. So if it's becoming complex, we will understand with a simple example. This is a diagram illustrating commute time anomalies relative to baseline. Let's say I travel from my home to office or home to college. Okay, we all travel home to college daily, and daily it takes us roughly 20 minutes. So if it takes us roughly 20 minutes means every time we can't go exactly at 20 minutes, correct? Sometimes we may reach at 25 minutes, sometime if the traffic is not there, we will reach by within 15 minutes, correct? So if 20 minutes is the average, that doesn't mean every time we will be reaching in 20 minutes. Sometimes it may be higher, sometimes it may take less time. Over a period of 30 years, whatever time we have, the average we will take it as baseline. So sometimes if there is more traffic, it will take us more time. So let's say 20 minutes is our baseline. So this base we will consider as 0. So this 0 here refers to our 20 minute. So 20 minute is our 0, and from here if it's taking us 23 minutes because of traffic. So one day we are reaching at 23 minutes. So this is 3 over here. So this 3 means 23 minutes, and this 3 here just represents the change with respect to our baseline. How much more time I have taken from the baseline, that is our 3. So similarly, if sometime there will be buses going around or there will be some traffic due to some reason. So if I am traveling behind the bus, I can't overtake it. So it may take us more time, so 7 minutes. So that means the total time is 27 minutes. The change from my average time is 7 minutes. So some days we may start early. So if I am starting early, there is no traffic, I may reach before 20 minutes. That is, if I reach within 16 minutes, that is my -4. So this is a simple example with our day-to-day work routine. So the same graph we will plot with for climate data. So this is an example. If you see, this is a deviation graph from 1950s to 2020s. This is the average temperature, average deviation. This line represents 0. So average temperature is your 0, and this is the change. Each year whatever change has happened, this is the change. So this graph we can represent with a line graph also. We will connect all these dots. So this data we can represent with line graph also. So this is temperature anomaly of New York during 1952 to 1990. So here if you see, this is a global map over here. This shows the difference from 1901 to 2020. Here if you see the global temperature in 2024, only the year 2024, it was above average from 91 to 2020. Here you can see in the graph, in the GIF, the graph is playing, right. in 2024 the temperature was higher than the average of total, and from 1976 to 2024 only 1 year was colder. In 1976 only that year was colder in 48 years. That was the only colder year than the average. Then rest of the year, every year the temperature is having a increased trend. Okay, every year the temperature is having increased trend from the average temperature. Okay, so these are the key components. We have already seen what's a base reference period is, that is our climate normal. The long term average, usually it's taken for 30 years, used as a standard climate normal for comparison of our annual temperature. Second is observed value. The actual measured value of temperature or rainfall recorded for each year is considered as observed value. Next is deviation measurement. The numerical difference between observed value and the baseline average, including the positive and negative anomalies. So, whatever the values which we have marked in our deviation graphs, right, these all are deviation measurements. So, whatever markings we have done, this +3, +7, -4, these are deviation measurements. Next is time series display. So, a chronological graphical representation of showing how deviation change over a time. So, whatever earth related data we are getting, whether it is temperature or rainfall, we can't plot everything on the map on top of each other, right. It will be like all the map will be stacked on top of each other. So, we can't predict exactly what is happening. So, we will create a time series chart like this. So, whatever time series analysis we do, we create a time series chart for that. Yeah, a chronological graphical representation showing how deviation changes over a time. So, now we have seen what a deviation graph is. We will see the procedure of how to create a deviation graph. We will take some data. For here, we will take a data of over a 10-year period, and we will create a time series deviation graph out of it. This is the procedure for deviation graph. So, these are the basic steps involved. So, what is the first step to create a deviation graph? The first thing is we need the temperature data or rainfall data over a period of time. So, first we will collect long term climatic data, whether rainfall or temperature. So, today we will be solving for temperature. For rainfall, the procedure is same. Only thing is you have to change the data, you have to do the same analysis with rainfall data. Second is we will select the baseline reference period for climatic normal. So, to calculate the climatic normal with the data, the given data what we have, we will select the baseline period. That is, if we want to consider the baseline as 10 years, 15 years, 30 years, we will select a baseline for climatic normal. Then we will calculate the baseline average. We will do the calculation. How we will do? So, whatever temperature, let us say we have 10 years data, temperature data, okay, we have it for 10 years, 20 degrees, 21 degrees, 22 degrees and so on, we have for 10 years. So, we will add all this data, we will take a sum of it and we will divide it by 10. We will add all the data, sum of observed climatic variable for a given number of years divided by number of years. So, we will calculate baseline average. Then once we have calculated the baseline average, we will be getting an average value, correct. So, what we will do with this average value is, so this 20, 21, 22, this data is there, right, first year, second year, third year, fourth year, all this data will subtract average from it. Then whatever value we get, that is our change. If the change is positive, that means it is hotter. If the change is negative, that means it is colder than the baseline. So, calculation of baseline average. So, once we have done it, we will compute the deviation, we will compute the change. How we will compute the change? The observed climatic variable of the particular year minus the baseline average minus the normal average. And so, once we have calculated everything, we will plot it in a graph. So, plotting deviation time series graph, in x axis will show time in years and in y axis will show deviation value plus or minus. If it is a 0 means it will be in baseline only. So, we can plot either bars or lines for each year. So, bar graph was there in example. So, line I have shown you, right, we can connect it and draw line graphs also for deviation. So, positive bars it will be above 0, negative bars it will be below normal. So, once we have plotted this graph, we can get interpretation from this graph. If there is any extreme changes, those things we can get insights from the graph as well. How, why the change is happening, everything we can get the insights from the graph itself. So, in this exercise we will create a deviation graph for temperature. Okay, for rainfall the procedure remains same, you can follow the same procedure for rainfall as well. You are going to create a deviation graph for given station based on historical temperature. So, here we are only doing for 10 years. So, here we have 10 years data with us from 2011 to 2020. So, this is the observed temperature for the particular year 26, 27, 26.9, 27.9. So, this is the observed temperature for the year. Now, we have to calculate baseline temperature. To calculate baseline temperature, what we will do is we will add everything. So, we will add, and whatever value we are getting right after adding this, we will divide the value by 10. So, it is around 295. So, if we divide it, we will be getting 29.5. So, the baseline we have set it to 29.5. This is our baseline temperature. Now, to calculate the deviation, what we have to do is observed minus baseline. So, here in year 1 the observed value is 26.2. So, 26.2 minus 29.59. So, same way for year 2 27.53 minus 29.59. So, with all these values, observed values, we will subtract 29.59. So, once we have done that, so here we are getting the deviation value. So, for the year 1 it is minus 3.39, year 2 minus 2.29, minus 2.69, and if you see it is getting hotter and hotter. See, previously it was cold, minus 3, minus 2, minus 1.69, then it is coming to minus 0.29 and 1.61, and it is going on increasing to 3.41. So, now we will plot the deviation of time series graph. We have found out all the variables, we have got the observed temperature from the data set, we have got the baseline temperature, and we have found out the deviation as well. So, we have all the data now to plot the deviation graph. So, whatever deviation we are getting, right, so this we have to plot it in a graph. So, baseline we will set it to 29.59. So, this 29.59 is our baseline. So, here I will make y axis and this is our x axis. So, here this is our base, okay, this 0 is our base. So, here this 0 represents 29.59 degrees Celsius. So, this is for our reference only, we do not have to write this 29.59 in the graph. So, this 0 is our baseline. Now, we have to plot all the changes. So, in 2011 the change was minus 3.39. So, yes, I will plot 2011, 2012, 2013, 2014, 2015. We will plot each year's graph and we will try to find out the change trend in the temperature 2017, 2018, 2019 and 2020. So, for year 1 it is minus 3.39. So, if the value is negative, what we have to do is we will plot it in the below the baseline. So, let this be minus 1, minus 2, minus 3, same way 1, 2, 3. So, minus 3.39, it will come somewhere here. Next is minus 2.29, minus 2.29, it will come somewhere between 2 and 3, right. So, next is minus 2.69, it will come somewhere here, 2.69. Then minus 1.69, 2014 minus 1.69. Then for 2015 it is minus 1.19, minus 1.19, then minus 0.29, minus 0.29. Then from 7th year it is going on positive direction. It is being 1.61, 2.71, 3.81, 3.41. Now, for positives we will mark above the baseline. Okay, so now 1.61, then 2.71, 2.71, 3.81, 3.41. So now we have plotted all the points. Now if we note this deviation graph carefully, here we can see a common trend, except this 2012 and 20. If you see, every year it has shown a increased trend. Here it's again decreasing, but after that, if you see, the graph is going on a increasing manner. If the temperature is increasing year by year. Okay, so this insights about the sudden spike in temperature, sudden extreme colds, extreme hot temperature, all these insights we can get from deviation graph. If we just have this table, here we can't visualize much things, correct? Only with this observed temperature, we can't come to a conclusion if the temperature is going high or low, or what trend that is following. We can't predict from this observed temperature. So even with deviation values, we can see a trend, right? It's showing a positive increase throughout. So the same way, if we plot it, here we can see clearly that except 2012 and 20, every year the temperature has been increasing year over year from the baseline. This is the deviation graph for the same one which we have plotted. If you see, only here it has gone increasing. Apart from that, every year it's increasing. So here we can interpret the trends and extreme events. If any climatic weather change happens for a particular year, everything we can get insights from this. So this is our deviation graph. We have done for temperature. The same way we can do it for rainfall data as well. But if you look deviation graph in YouTube or other resources, mostly this deviation graph they may have used for some other analysis. They would be doing for marketing stuff or some other subjects. Okay, it may not be specifically for climate, but yeah, so be careful with the study materials which we are preferring. So now we will see some of the points to remember, key takeaways. So deviation graphs highlight climatic anomalies. It distinguishes normal variation from the significant shift. Variation is our baseline, and whatever the extreme climatic conditions are there, all things we can get insights from deviation graphs. They reveal patterns, trends and extreme events that raw climatic data may hide. So if you see the table, right, so with this table we can't depict much, we can't see if there is a positive increase in temperature or there is decrease over a period of time. We can see the temperature in that particular year, but we can't get an insight of how the pattern is going. This insights we can get from deviation graphs. So it reveals patterns, trends that raw climate data may hide. Useful for climatic assessment, planning, decision making in sector like agriculture and disaster management. It provides us a simple and clear visual representation of long term behavior. So the long term climatic data, 30 years, 50 years, so whatever the behavior is, everything we can depict with a deviation graph. So we have again done an exercise which covered the computation of deviations, plotting graph and interpreting anomalies. So the exercise which we did, right, we had only one variable as given data, that is the observed value for 10 years, that we had a given data. Then we have calculated baseline and we have also calculated the deviation, the anomaly. So after calculating it, we have plotted that in a graph. Thank you so much everyone.